Hi, welcome to clickmyproject.com. Now we are going to see the process of to lie or to comply defending against flood attacks in disruption tolerant networks. Here is the abstract of our process. Disruption tolerant networks or the mobile networks. It consists of mobility of nodes and also it has a limited buffer space and it is also vulnerable to flood attacks. Here we are using rate limiting method to defend against flood attacks in disruption tolerant networks. Here we use the method climb, carry and checks. It adapts that each node counts the number of packets and sends the counts to other node. So that here we are using trusted authority. The trusted authority verifies the count and provide a rate limit certificate. So the each node passes the rate limit certificates to every node. Based on the rate limit certificate, it verifies the rate limit value from the packet count, so that it is matched with the particular node is valid node. Otherwise, it is considered as an attacker. So the receiving node uses the climbs and cross check to find the inconsistent when the nodes are contact. So that we have to identify the malicious nodes behavior. Here is the DFT of our process. Here first we have to initialize the nodes for our network formation. After initializing the nodes of our, we have to declare the source and destination of our process. So the packet transformation in between the source and destination. Then move to the pclaim and declaim process. Here before that move to that process, we have to consider that file splitting process. Here we have to split the file into number of packets whenever the transmission is occur. Then move to the exchange metadata. Here each and every node transmit their node ID and transmission count and rate limit certificates and packet count values to that every neighbor node. So that rate limit value is generated from the trusted authority based on packet size counts. So that after retrieving that ID information and packet count value from the trusted authority, the source node sends the information to that nearby nodes. So that in each and every node it have the rate limit certificate value. So that node verifies the rate limit value with the packet sent by the source node. If it is matched, means it consider it's a valid source node. Otherwise it discard the packets. Then moves to the next neighbor nodes. So that for the n packets we have to generate pclaim and declaim. After verify that packet with the receiver, receive the packets. If it is then moves to the check for inconsistent process. Inconsistency means we have to verify the climb checking process. So that here the transmission count and also the packet count is greater than the rate limit value, means here we have to identify malicious behavior is identified in that process. So that we have to identify the source node of the packet sent received from that source node. So the particular node is identified as a attacker. If it is true means check inconsistent and store that new claims. If it is fail means we have to discard packets. So that we have to easily evaluate the malicious behavior in that neighbor nodes. Now we have to see the demo of our process. Here first we click the home.java. Then move to the node creation process. Here by clicking network formation, enter the nodes limit. We have to enter the network formation. Here the node limits is S1 S2. The node start destroyer. We have to the connection path. Here the based on the neighbor node, the connection is trotted from data runs occurred. Then move to the next process. Here we have to choose any file for data transferring. So that file is split into buses. So here split procedure is split contents 5. The split size is 2 KB and that file name is attack.inp.txt. Then move to the splitting process. The file are splitted successfully and stored in that location. Then move to the next process. Here we have to choose the splitter data list. Here we have to select any splitter data. The data is displayed. Then move to the climb process. Here we have to display the packet count and packet size. Then the intermediate nodes are displayed. Then move to the run that trusted authority.java. Here is the ta.java. Here in source node we have to click the keys sent to that, so that the keys are sent to the trusted authority and the neighbor nodes list are sent to the trusted authority. So here to see the source node ID and move to the process means. Then trusted authority evaluate the key generation. Then show me the key algorithm. So that we have to cover the rate limit certificate for that file. So in that process we have to move that next process. Here Here by clicking send limit means the rate limit value is set to that source node. Here by clicking send, the value is received from node. So we have to evaluate that neighbor node is SN2. So that here the rate limit certificates are generated. The certificate rate limit values are that node ID. These are the values are generated, and by clicking send certificate means that value is generated to the receiver side source node 1. Here we have to evaluate the node ID and packet count and transmit. So these are the packets are transmitted from source node to SN2. Then we move to that next process. Here we have to run the sn2.java. For transmitting process we have to run the sn2.java. So here the sn1 send that id to that sn2. Here by clicking node end means the id was received. Then the packet count also. And we have to see the transmission count. In that version receive transmission count, and also send the send rate limit certificate value. Here also receive the rate limit certificate value. Here by clicking transmission count node, here the SN2 transmission count is calculated, and also the neighbor node for next transmission of SN2 to SN3. Then we have to give the acknowledgement process. Here we have to click the acknowledgement process. So that in that process we have to click that send acknowledgement to source node 1. In that process the RAM is noted. Here the SN2 responds successfully. So that validity is in that 11 seconds it has to go the validity in that SN2. So that we have to send that packet to SN2 by clicking send all. Here receive all means the process release. Here by clicking claim carry means the rate limit value send the packet count, so that here the SN1 is valid node. Then moves to the transmission from SN2 to SN3. Here by clicking data means the SN2 source node data are stored in that claim carry checker process. Here we have to evaluate the malicious node behavior means we have to run the packet flood detection.java. We have to detect the packet flood detection. Here is considered as an attacker, so that in intermediate that SN3 the attacker is incoming means here that ID is retrieved from that attacker. So that here by clicking send ID means here the node ID is received, and also send packet count means here the packet count is also displayed, and also send rate limit certificate means here also receive rate limit certificate, and also send transmission count means here also receive the transmission count, and also here the transmission count the neighbor node is base station. It also displayed. Here also the if send the packet means the SN2 start the acknowledgement process. Here the packet means send acknowledgements means the acknowledgement received. Acknowledgement received. So the here the SN3 validated successfully. So that SN validated in that seconds. Here we consider the button, so that here then attacker sends the data to that base station means here we have to run that base station process. Attacker send that ID means here by clicking send ID, here by node ID, the node ID will be displayed, and also the updated packet count is to be sent to that base station means here the packet count will be displayed, and also send that rate limit. Here also by clicking receive rate limit also received, and also send transmission count value means here by clicking receive transmission count are displayed, and also transmission count and then neighbor node has to be displayed. So that for that process we have to move to that acknowledgement process. Here by clicking that acknowledgement process, waiting for acknowledgement. Here by clicking sending acknowledgement, the acknowledgement send, so that the response time is evaluated. Like that the node is to be acknowledged, the time is to be evaluated in that process. Here that acknowledgement successfully, so that by clicking send all packet means here by clicking receive the packet will be received, so that we have to verify the client limit, so that here the packet count is greater than the rate limit value, so that invalid packet count, so the SN3 is an attacker. Thank you.